Hi, my name is Ryan Higgins, and this is an exponential growth problem for AP Calculus. The rate of increase of the population of a certain city is proportional to the population. If the population in 1930 was 50,000 and in 1960 it was 75,000, what was the expected population in the year 1990? So here we have the time and the population. At a time of 0, which correlates to the year 1930, there was a population of 50,000. At a time of 30, or the year 1960, there was a population of 75,000. And at a time of 60, or the year 1990, that is the population we are looking for. So to figure this out, we will use the exponential growth equation. P equals AE to the KT. P is population, A is a fixed amount, K is the rate of growth, and T is time. Now let's use the exponential growth equation to solve for K. So we'll start with the original equation and plug in a time of 0, which correlates to a population of 50,000. We will then use this to solve for A, and we get A is equal to 50,000 because e to the 0 equals 1. We will then use this and plug it back into the original equation for A, then use the second point of 30, time of 30, that correlates to the population of 75,000. We will then use this to solve for K. If you divide by 50,000, you will get 3 over 2 equals e to the 30k. You will then take the ln, or natural log, of each side. This equals k to be 1 divided by 30 times the ln of 3 over 2. To get a decimal approximation for k, this is how you will put it into your calculator. You will do parentheses 1 divided by 30, close parentheses, times the ln of 3 divided by 2, close parentheses. And you will get 0.01351555036. Now you can store this number, or you'll just have to type it back into your calculator every time when you're plugging this number back into the original equation. So now we have k as our decimal approximation of 0.01351555036. With this, we will now use the k value and solve for p. So we will use our k value that we just solved for, and a time of 60 because we're solving for the year 1990. We will plug each of these values into the p equation, and then we will put this in our calculators and solve. So we will now put this into our calculators. We'll first start with 50,000. Second, ln to get e to the 0.01351555036. In parentheses, multiply that by 60, which is our time, close parentheses, and you will get. So now that we solved for this value using our calculator, we get an answer of 112,500 as our population in the year 1990. I hope that this math video helped you, and you can now solve an exponential growth equation. Just remember that you can solve any math problem as long as you have confidence in yourself. Thank you.